Good afternoon, everyone. Thanks for attending my talk, The Better Track. I'm standing in between you and lunch, so I am aware that I will keep it punchy, but I am asking for collaborators. I'm asking for curious people. So, hi, my name is Louis de Sousa, and I am speaking about Duck Safari. So essentially, this was born out of play. I was like, I wanted to play with two technologies, and I was like, let me make an excuse to use them. And the subtitle is Hunting CVEs in the Shadows with ShinyLive and DuckDB-WASM. And I guess I was inspired by the theme of the conference. So I said, how do I keep it relevant? How do we speak about the sort of underlying algorithms? So today I'm representing two different communities. So this is my shameless plug. So I am representing the Johannesburg R user group. So R is essentially a statistical modeling language that is made up of an ecosystem of packages. So there's more than 10,000 at the moment. We meet once a month, every second Tuesday at the Microsoft offices. And you can find us at rusergroup.coza, and the meetups are posted on meetup.com. The second community I'm representing is PyData. So essentially, this is for the Pythonistas, so people who use Python and data. We meet at City Rock, so the rock climbing gym. Yes, that one. And we do some rock climbing, actually, every second Monday at 6:30 in the evening. So if you want to do some data and climb, we're always happy to have you. Okay, so why am I here? So I had a telephone conversation yesterday, and someone was like, why are you doing this? Is this your job? Is this what you do? And I was like, okay, so that's where the slide comes from. My boss didn't tell me to do it. I'm not, I'm not here for attention and clout and for all those other things, but I think this is about play. And I think it is actually about curiosity. And fundamentally, the actual real thing is we need to be curious in life. I think all of us need to be, but not like manufactured curiosity, but like being like, hey, what's going on here? Because the actual real, sort of 0 day is losing interest or curiosity. Okay, so onto the topic. What have been told to see? So in a lot of cases, we have proprietary dashboards, or we're working within large corporates, and we're very much removed from the underlying data sources. So I'm largely a data guy, so we like playing with lots of data and understanding all these different complexities. And a lot of times we would look at dashboards, we run KPIs and sort of threat metrics, and we don't actually know the underlying logic. We just go find red, amber, green. We can, certain numbers, we start chasing things. And if all these data sources that we're consuming are open, then sort of why does everything kind of feel a little bit hidden? When you ask people to start defining acronyms, all of a sudden everyone's like, I don't actually know what that acronym. Yeah, good question. I don't actually know what it is, and you notice it when you start entering different fields. So this is very much, for me, it's like the iceberg analogy, where sort of on the top, like most dashboards you see have been sort of pre-churned. There's lots of logic and thinking that's gone behind it, but you're not necessarily aware of it. And especially when you're looking at like scoring algorithms, and certain data gets lost. So it turns out with CVEs, I found out that, there's actually, there are certain ones that can be rejected. for whatever reason, it states in the documentation that they can say they can remove entries. So this is, think of this as traditional dumpster diving. You're like, you're looking at just, hey, what's going on here? Okay. Are you seeing risk, or are you just seeing what you're allowed to be seen? So, as I mentioned, and this picture is really great because things get just, things just fall off the, because I guess there's only so much time and only so much complexity you can understand. And a lot of times, if you're able to understand the raw data sources, you can actually, and have the ability to manipulate it. That's where the real power comes in. Now, in a lot of cases, it takes a lot of time. So a lot of time to process the data and actually understand it. But once you've got that understanding, you can actually pick up some really interesting trends and actually understand what's happening. So what would we see if we could choose the filters on the data that we have? Okay, so CVEs essentially are publicly published on a nice GitHub repository, and there are a few thousand JSON files. Every night there's 400 megs of JSON files. I think it's, probably 5, 6, 7,000, a lot depending on how far back you go. And essentially, we're able to use these JSON feeds to see all the current CVEs that are being created and some of them that have been deleted. And this is the raw data we can now start playing with. So now what's interesting about the CVE data source is it contains JSON information. So think of it as, when we speak about data in general, think of like most relational databases are like sort of Excel spreadsheets. You have a column, you have a row, and you're able to extract data out of it. Now, what's interesting about JSON is we can start nesting data inside it. And that's kind of what makes it really interesting, because you actually need to understand the structure of the JSON that you're getting to actually start extracting some interesting information out of it. And that's actually largely determined by the schema. So there's actually on the CVE GitHub repository, there's also a schema that says this JSON should always look like this or follow this structure. So very structured. So it's highly structured, but obviously it can contain sort of nested information, which is interesting. So in my case, just for this example, I've chosen the withdrawal field. Now, I was like, okay, so things can be withdrawn. So let's see what happens. So let's show you a raw CVE record. So one thing I didn't open. Right here. Okay, so in my case, I downloaded all the CVEs of this morning, and they are currently exactly. Okay, there are more than 100,000 CVEs that my poor machine has had to extract. And okay, so a CVE is JSON that looks like this. And essentially, it's nested data with each of the vulnerabilities, when it was reported, who essentially reported it, and so for example, in this case, this was a SQL injection, and who the vendor was. So it's a PHP. Who still use PHP? Anyway, it's really popular. And obviously a bunch of metrics. So these are the CVEs metrics that have been created that they determine. And so in our case, what we're going to do is we're essentially going to flatten this data. That's essentially kind of the essence of what this talks about. Okay, so CVEs are open data, so we can all go download them, but they are messy. So I think when you realize that nested structures turn out to be quite large tables, and it gets quite complicated getting into the sort of the essence of it. So I'm kind of going to explain to you a bit of a pattern of how, from a data perspective, how we start processing these things. And generally, dashboards are very much, they're relational. So you're not going to get your fancy NoSQL database, because it turns out dashboards are just sort of us summarizing information and sort of surfacing it, which is more of a relational thing. And without this, and essentially with that clarity, we don't need gatekeepers, we don't need vendors, we can make our own sort of narrative around what's happening. Okay, so let's build our own tool. Okay, so I've chosen the 3 things that I wanted to play with. So DuckDB. So DuckDB is the analytics version of NoSQL. So it's an in-memory database that is essentially it's a highly performant analytics database. So think of it as a pivot table engine. It's probably the easiest way for me to explain it, where SQLite, for example, is a very lightweight in-memory SQL database, and DuckDB is the analytics equivalent of that. So what's interesting about that is if you want to average things, if you want to do more complex like windowing functions, like understanding different periods, it's highly performant because it's optimized. Essentially, it's built from the ground up and started out of the Netherlands, and these are database researchers. So this isn't a big data, sort of Spark engine that like needs 1,000 clusters or whatever. This is essentially a little small, highly performant in-memory database. Now, what's interesting about this is we're able to handle billions of records, that's billions of the big B, inside a little in-memory process. I don't need to spin up a cluster and stuff like that. I can actually sort of summarize billions of records inside this small little engine, which makes DuckDB very powerful. So ShinyLive is essentially a in-browser framework that allows us to create front ends or dashboards fairly easily. The difference with this is essentially we don't need a server to host like your React application or your PHP application. This essentially is all running in browser. Now, that just means it has a fairly large JavaScript payload, but essentially you're running this all inside your browser, where you're able to actually play with the data. And the last one was duckplyr. Good old duckplyr. So essentially within the R ecosystem, there are a bunch of packages. And this was meant to make my life easier. But unfortunately, it did not. So I did not use it. So largely, so ShinyLive, I must mention, it's for Python and for R. And essentially, it's just a way of creating user interfaces and then creating like a website or interactive website. So essentially, you can have a static website, and then you have ShinyLive is that interactive website. So you can interact with code, interact with R or Python code, or C++ if you're that way inclined. Okay, so install 100% client side. Okay, so in our case, so from a super high level, we have the CVE JSON that we can download from the official website. we're essentially running DuckDB inside the WebAssembly, so inside your browser. So that comes with a sort of caveat. So you're only allowed 4 gigs of memory, which is more than enough if you're just running a little dashboard. And it is also the typical browser, modern day browser is very hungry anyway. I'm sure most of your, sort of Google or any sort of browser that you're using is just using a lot of memory anyway. So I don't think this is it's not a deal breaker. And in a lot of cases, this essentially works on most modern day browsers. You can run it on any provider. There's no limitations or anything. Just you and your data, man. So in our case, the guys who created DuckDB are, dare I say it, database connoisseurs. They've essentially taken every single possible gripe that you would have with extracting data and like understanding it and sort of trying to clean it, and they've like essentially created functions to help you. So in our case, with one line, I'm able to import all the JSON files for 1 year for the CVEs, and it selects star from read JSON auto, so it automatically determines the schema, and that's it. I'm like, damn, that's pretty cool. I'll show you the code. So I think what's really nice about this is it has more advanced features like schema evolve. So if the schema ever changes, it will automatically start adding columns, and flattening data. So although I have to admit though, JSON is a very hungry process. So you would be running this either server side or on a larger machine. My poor little machine can manage, but you would obviously need a bit more horsepower sometimes if you do more complex JSON parsing. Let me quickly show you how that looks like. I'm using good old trusty dbeaver, so it's just a database client. And I've essentially, so DuckDB is a in-memory database. However, you can also persist it to disk, meaning I now have a little DuckDB instance in memory, and it essentially can then saves it. I can save that actual database to disk. Now it follows a sort of PostgreSQL. So if any of you have ever used PostgreSQL, it's the same sort of schema. And so it's like it's a schema that we know and understand. And now we have this sort of all these analytic functions which help us. And I'm just able to create a table, in our case like raw CVE. And I'm saying, please give me, essentially read all the JSON files from this directory. So I'm saying, give me all, I downloaded it this morning, all the CVEs for 2025, and I just chosen a specific directory. And there are about 100 JSON files in here. I don't want to be too enthusiastic, and essentially I'm saying include the file name. And I can actually show you how it looks like in the simpler version. So in sort of, I don't know, less than 2 seconds, I've essentially imported all the sort of JSON files, all 106 of them, and I've flattened them. And I've also, I have a nifty function that I included the file name, so I can tell you exactly where it came from. And I just said file name equals true. So this essentially went into the directory, took every single, it passed all 100 files, and it imported all of them, and then it essentially flattened it into a database table. Now, if we want to get a little bit more interesting, or a bit more spicier, we can go into, there is, for example, in our case, there is a CVE metadata field within the JSON, and you can start now pulling out specific fields. So within that hierarchy, that JSON that I was showing you, there's a hierarchy of information. So you can embed, information in information, and you can actually now start pulling data out of it. And in my case, I quickly pulled out who the assigner was, the publish date, and the state. Is it published? Or in our case, there's this interesting thing which I'm like, okay, rejected. Okay, that's interesting. So actually there's a whole lot of, so within that specific folder, there were 11 CVEs that were rejected. So someone has reported it and then someone rejected it. So what's interesting is they then just mark it as rejected, leave the number, and then clear the data and be like, okay, well, it was rejected. And in our case, just to, I sort of added a little bit of an extra thing where, and I'll explain why, but I want to export this table that I've created. I've essentially created a table now. I now have a database table that we can, if anyone is familiar with just normal databases, just select star from a database. I'm just getting data from, give me all the table, give me all the columns and rows from the specific table. Now this is living inside DuckDB, and in our case, turns out DuckDB can also read Parquet files. So I've essentially now taking this table and I'm exporting it to Parquet in one line, saying, give me this table, the raw CVE table, and create a Parquet file. Okay, so why am I doing this? Turns out that Parquet is highly optimized for the HTTP protocol. And you can start doing sort of, if you have large data sets, you can start partitioning it. I haven't done the code for it, but I'll tell you, I'll gladly tell you why I've done it. That's the actual trick where you can now put this on a S3 bucket, on a Azure bucket, and all of a sudden you're able to query it and you can now filter it based on a certain directory, which is essentially a partition. Now all of a sudden you're able to now partition and get highly performant queries, because it turns out that DuckDB can query the file essentially sitting on a public cloud, and they can actually fast forwards and rewind and actually understand the structure of the data and only get back the data it actually needs. Pretty handy. Okay. In the cases when you understand the actual underlying data, you can now start filtering it and creating your own sort of dashboard. And that's kind of where I've gone with this project. So in the case, if you understand the data and you can create, so now you can start creating your own dashboard. Okay, so in this case, I've essentially used a ShinyLive application. It is, can everyone see? Cool. It is 180 lines, and essentially this is a user, think of this as a way of articulating a user interface and sort of a graph that essentially we're actually now playing with our graph. But before we go there, let me quickly show you the Parquet file. So the Parquet file that I just exported looks like this. So I'm just using it, I'm using VS Code with a Parquet add-in. And this Parquet looks mighty, you know, it looks pretty much like that database, like that DuckDB database. But turns out it's in this open format that most sort of data systems can sort of start ingesting that data. Now, in my case, I'm using, within ShinyLive, I'm using dplyr to, so I'm using DuckDB to import the Parquet files. So why am I doing that? Because if I want to summarize billions of rows, or even hundreds, or in memory, I'm able to use DuckDB for that. The reason I use Parquet is so that we can sort of partition it, so it makes it highly scalable. So in my case, select the code. So I'm obviously showing it to you within VS Code, but this obviously I will give you the source code to my presentation and to this, and essentially you will be able to view this in your browser as is. But as okay, so essentially what I've done is I've just created a dashboard, super basic dashboard, just saying, hey, these are the number of CVEs, we can play with the date, we can change the CVE assigner, we now have multiple sort of tabs, and we can start playing with the underlying data. Now this is now driven by just a small little file that I've created. Think of it as like a cleansed source. And if I want to make any sort of change, it's literally, it's one line of code. If I want to sort of within your GitHub repository, you can literally just rename something quickly and the interface then will change automatically because it's happening all in browser. Because as your browser downloads the latest version, it will always be the latest iteration of it. So I think I originally started using different data sources for this talk. I actually used the Google CVEs data source, which was essentially an amalgamation of all the security open source security alerts, and I only realized beforehand it was like, okay, these are only open source. And what's really great about this is if you're able to take all these sort of different data sources, so it turns out Google has their view of the world, CVE has their view of the world, you can find lots of data, and it's actually quite extendable. And I have, in my next slide I'll show you, but essentially you can expand this, to sort of, how does it look like for SBOMs? So like within your software supply chain, what does this actually mean? So I'm kind of showing you in a basic way that you can start importing all these data sources and creating your own sort of dashboards and narratives out of it. And you don't need this high-powered server. You don't need any of the vendors. Essentially, you can iterate by yourself quite quickly. In most cases, most vendors or people have a specific point of view. And I think a lot of this is being very deliberate about creating your own point of view in the data sets that you're getting. And even really popular data sets, you don't realize that actually things are actually falling off that you can actually sort of bring to the front. So essentially build your own lens on what's going on. And I think that's kind of what a lot about the theme of this conference is, where if you're not curious and you don't say, okay, but look, why are we doing it this way? And why is this a standard? Or why can you withdraw a CVE and like it just disappears? Turns out the data is there, you can go fetch it, but might be interesting, might not be. But are you going to be curious? Like, are you just going to be like, well, the dashboard said 7. So that's the number, guys. 7, who chose 7? Might be 42, but we don't know. Okay, so in this case, okay, so who would use stuff like this? So sort of red teams for a bit of like recon and prioritization, policy audits and control mappings, SOC dashboards without external dependencies. Like there's lots of different ways, and I've added as well, like you can do exploit DB integration, so you can start pulling that data, put it inside your own dashboard. You can do sort of SBOM aware filtering. So all of a sudden, now within your software supply chain, you can start now filtering all that information. You have this large database. Turns out, if you ever want to productionize this is essentially, this is a normal database. So it very quickly leans itself to something that you've can play with, and then it can evolve into something a lot larger. But for iterating and playing and understanding what is the actual problem that we're dealing with here, I think this is it's a fun approach, and you'll be well served using it. I will publish on my GitHub repository in the next few minutes. The CVE Explorer, essentially the source code of the dashboard. And you can like play around with it. If anyone feels like that it can sort of be better, I'm always happy to sort of collaborate, be lekker, you know, that's and in a lot of cases, this is just within your browser, and it's, yeah, just have some fun, guys. I think that's what this is about. Fork, extend, and share. So I've maybe learned the hard way that visibility isn't always something given, or sometimes it's appreciated. I think it's a very difficult, and sometimes, you know, visibility isn't. People ask questions, get too anxious about it, want to run away from it. But if you're willing to hold it, I think it's something very powerful. And as kind of was said earlier, like even within the social media sort of sphere, or what all the news or the things that we consume, it's like you can define what you sort of your lens on things, and you can actually make sure that the things that, or the lens that you're choosing is based on the things that you value, not sort of made by some sort of weird third party. Walk your own path through the data. And probably through life as well, guys. Yeah, so always happy to collaborate, and the mic will be passed around. Does anyone have any questions? There are lots of other fun side paths that I had that I did not have enough time to mention, but this was lots of fun to kind of sort of play with this idea. Cool. Do I have any questions? Cool. Can you get the mic, please? Thanks.
Check 1, 2. Sorry.
Thanks.
I suppose regarding the sanctity of that GitHub database of CVEs, so once a vendor declares something as rejected, it kind of just fades off into the background, but it is still there to go looking for it. Are there any legal avenues that a vendor could take to scrub it for good and basically like kill the data entirely? Or does it rely on enough people downloading it often enough that someone can always come back and be like, hey, actually it is still here?
So I think my understanding is, as I said earlier, this is kind of like dumpster diving, right? Where I've seen some research. I've seen one interesting research paper where the researcher has looked at some sort of redacted sort of CVEs and tried to understand the trends behind it. I think in a lot of cases, data appears, then disappears for whatever reason. And so, like from a legal point of view, they would obviously say it was a false alarm. It wasn't. It didn't necessarily affect us. What's interesting is there's actually a DuckDB CVE. Turns out, a vendor, Grafana, they used DuckDB inside. They were like, this is a great tool. Let's use it inside our within our technology. Problem is they use the CLI version of DuckDB. So the problem with the CLI, guys, is it has access to your root, to your machine. So it's like they were busy, it was a hackathon actually, and they quickly like hacked something together, and then it was like the next minute, like, okay, you just made this giant gaping hole in your application because you've it was a quick thing that you did. So I guess to answer your question, I guess there are always. It depends, guys. It really does, because I think a lot of cases, some vendors will swear that certain things don't happen, right? Like, it's sort of perception and stuff. It's not popular. Cool. Anyone else? So your top tip: don't use CLI, guys. There's a CLI stuff. There's a Python library. There's lots of other libraries. Don't use CLI, please. Please, please, please. Thoughts? Anyone disagree? No, silence, stunned. Yes. Oh, okay, we've got one other question here. Let's go. Can we get the mic, please? You,
So with the CVEs, you showed that you collected the rejected ones as well. I might have missed it, but was there any data in those CVEs, or were they all scrubbed?
so what happens is, within the nightly CVE extract, they essentially scrub the CVE when it's been rejected. But essentially, if you're downloading the data, so if I had more processing power, essentially there's a delta there's a delta that's created every day with the change of every single file. So if you're consuming the delta, you'll be able to pick up the actual text that it was before. So if you're watching the feed, or actually looking through the feed as it's happening, you'll see what was the actual text. But if you get a point in time of today, it's been scrubbed. So you actually need to go back to that delta.
Okay, that's cool. Any thoughts to maybe include that historic data in that rejected CVE?
So essentially, that's essentially what I'm saying in a roundabout way is, with DuckDB, you probably have the best chance of doing that because it's so performant and it's got all these functions that you can really quickly start importing all these things. You could probably go back, with a little bit of time, and probably in under a week, you could probably get all the data, clean it, and have all that historic data. So it's just a bit of fun. There's a bit of sticky points that you need to get over.
Okay, cool. I just wanted to know, what are we doing with the rejected data that seems blank? So I just
Yeah.
wanted to
So at the
understand
moment,
historic part.
at the moment they just scrub it. They're like,
Cool.
on the inside the schema it says determined by CVE. They're like, they've determined it's rejected. But someone at some time thought it was a problem and they logged the CVE. They went through the process of creating it. I don't know. Because it's a globally unique number, so they essentially it's almost like a database ID, right? Because it's a unique number, they have to start incrementing the numbers, and so they have to keep the number. Cool. Is that it? Otherwise, find me, and if you want to come play with it, give me a shout. Cool. Thanks a lot, guys. Thank you.